All right, so let's get started with our first video. We're going to be covering lesson 1.2, measuring and constructing segments. There are going to be several things that we talk about in this video that we will practice in the classroom, including the constructions. I'll show you an example of construction at the end of this video. Before we begin, though, it's always a good idea to have your index cards or flashcards already done with your vocabulary words before we start this. That way, if there's anything you want to add to them, you can add to them. If you want to take notes along the way, you can take notes along the way. So again, this first section is lesson 1.2, measuring and constructing segments. So using the ruler postulate. First off, one of our first postulates that we're going to be using is using the ruler postulate. Whenever we have a postulate or an axiom, it is something that is accepted without proof. So those are our first two vocab words for this section, postulate and axiom. Later on, we will be using those to actually prove theorems. So a theorem is something that's proven by doing a proof. We'll go through the process of using the axioms, the postulates, properties, other rules of math in order to show why something is true and why we're able to say things. And those postulates, axioms, theorems are things that you will have to memorize because we will use them throughout the year. So they go right along with our vocabularies. If you want to keep index cards or flashcards of the postulates and theorems as well, you are more than welcome to. Again, it's not a bad idea to have those. I'd keep them separate from your words that you're defining. So if you want to keep some separate flashcards for those, again, it's a good idea as well. Now, our vocab. So going down the side, we already just talked about postulate and axiom. We also are going to be talking about coordinate, distance between 2 points, constructions, congruent segments, and then also between. Now, I did change some of these slides out of order, so they might not go quite in order with how the vocab is listed. But the first thing here is the ruler postulate that I just mentioned on the previous slide. So the ruler postulate, the points on a line can be matched 1-to-1 with real numbers. The real number that corresponds to a point is a coordinate of the point. So on here, they're showing you a line, line AB. They have coordinate points listed as x1 and x2. And you're going to be able to use those points to represent real values. Then below this, you have distance. The distance, which is something you've done in algebra, between points A and B are written as AB. Notice, before we talked about a segment, and when we talked about a segment, there is a line over top of A and B. So here we have line AB. We want to know the distance between A and B. So we want to know the length of segment AB. Here, though, they just have the two letters next to each other. So that distance is represented by AB without any notation over the top. So again, we're looking for the absolute value of the difference between those numbers, which again, that's something you did in algebra. You found the distance by taking one number, subtracting another number. If it came out as a positive number, great. If it came out as a negative number, you changed it to a positive number. Again, that's what absolute value is. It's the distance away from zero. So on here, we're going to subtract the two numbers. It should always be a positive value. In geometry or any math class, when we're talking about distance, it's always a positive number. In science class, you might be like, well, we have negative distances in science. No, you still have positive distances in science. However, if you have a negative with a distance, it's showing a direction. So like if you were to go backwards, take 5 steps back, you might have -5. But the distance itself is always a positive number. All right, the first example, using the ruler postulate. So measure the length of ST to the nearest 1/10 of a centimeter. We're going to measure some lines in class using our textbooks and some rulers. But on here, we're just going to look at the slides. So measure the length of ST to the nearest 1/10 of a centimeter. You'd have to take your ruler, align it to one side of it. So you're going to align it with S, and then your other side to T. Now, you can start at 0. You don't have to. If you look at the diagram here, you'll notice that they started S at 2 instead of starting at 0. That's fine. You take that distance. So we have 2 is assigned to S. You have T then would be 5.4. You then can find the difference by subtracting. So we have the 2, we have the 5.4, subtracting them. We get 3.4. Again, it's a positive number already. So we're good with that number. If we had switched it around and did Let's say we had started with our t value first and we said t minus s. That still works. We would have got negative 3.4, but we still would have got 3.4 in the end once we take that absolute value. So again, the length of ST is about 3.4 centimeters. Then we have congruent segments. All right. Anytime we talk about two segments that are the same length, they are congruent. Now, congruent is a little bit different than equal. When we use the word congruent, we're describing the figure itself. When we talk about equal, we're talking about the length. So two segments that have the same length have equal lengths, and the two figures, the two segments themselves, are congruent. So you can say the length of AB is equal to the length of CD. And again, that's segment AB and segment CD. Or you can say that segment AB is congruent to segment CD. The symbol there with the little squiggly line and the equal sign means congruent to. So again, that's an important symbol to know. I make sure that you have that symbol written on your card so that you know that that means congruent. There's also a notation with a little tally mark there, or a tick mark, whatever you want to call it. You have the two lines A, B, and CD drawn below, and they have a little red line drawn on them. That is another way to show that they are congruent. Now, again, it's important to note how they have the difference between equal and congruent. They have the equal sign, they have AB and CD listed there without a bar over top. So that's saying the distance of AB or the length of AB is equal to the length of CD. Whereas on the other one, we have the bar over top. So now that's talking about a segment. And then the segment, the figures, they are congruent. So we have segment AB is congruent to segment CD. And again, there is a difference. Again, when you're talking about proofs a little bit later on, if you know something's congruent, then they're going to have equal lengths. So now for the second example, comparing segments for congruency, it tells us to plot these 4 points in a coordinate plane, then determine whether segment JK and segment LM are congruent. So we have our coordinate plane. We can plot those 4 points, and then we have to find the distance between them. So we're going from, notice, those two are in line horizontally. So we can just look at that horizontal distance between them. It's on a coordinate plane. We could count the difference. We could subtract the X values. Either way works. For the L and the M, they're going vertically. So again, we can either count the distance or we can subtract the Y values to find the distance. So on the first one, using the X values, we have the 2 and the -3 are our two X values. We subtract them and we get 5. Again, if you had done it the opposite way, that's fine. We get -5, but since we have absolute value bars, it's still going to be a positive number in the end. So +5 is our answer. On the other one, we're using the Y values. So we plug them in. Our Y values on that one are 3 and -2. Again, the order doesn't matter. It's going to become positive in the end. So -2 minus 3 gives us 5. So we have the same length, which means that they are congruent to each other. Now, using the segment addition postulate, when 3 points are collinear, you can say that 1 point between the other two. So on here, we have A, B, and C on the first diagram. B is between A and C. It's on the same line. Right? It's on the same line. It's collinear, and it's somewhere between them. It's not in the middle. It's between them. On the other one, you can say that E, which is off of the line, is not between D and E. So again, even though it's on the way, you can't use the word between there because E is not on the same line. All right, so now segment addition postulate. If B is between A and C, then the length of AB plus the length of BC is equal to the length of AC. Again, notice how I read that. The length of AB plus the length of BC is equal to the length of AC. So again, we're adding up the lengths to get the overall length of the entire segment AC. So if AB, the length of AB plus the length of BC is equal to the length of BC, then B is between A and C. So again, that whole thing is a widely accepted rule in math. That's why it's called a postulate. It's accepted as true. It doesn't need to be proven. All right. All right. On this example, using segment addition postulate. So now they put some numbers in there. The first one, it says find DF. All right, we have 23, we have 35, we have those two. We're going to add them together. 23 plus 35. If we add those together, is going to give us 58. That's the entire length of DF. Same thing for GH. They gave us two lengths. They gave us the overall length. They gave us the length of FG. We can subtract those to find that missing piece. So we're going to take the entire thing. We're going to set up our equation. Notice they set up the same way. They plug the values in. And then through subtraction, because we're going to subtract that 21 from the other side, we're left with 15. That is our other value. So GH is 15 units long. All right. Oh, I didn't mean to put the self-assessment in there. We'll save that for tomorrow. Constructing and comparing congruent segments. This is something we're going to do in class with compasses as well. So a construction is a geometric drawing that uses a limited set of tools, usually a compass and a straight edge. That's the only tools we're going to use when we're talking about a construction. So we're going to use some of those in class tomorrow. We're going to get a little practice using them in class. There are a couple different types of compasses, which I will cover at the end of this video. So again, a construction. Now, these are the steps for the construction. So I'm going to put them all up on the board here, and then we can talk about them. All right. All right, so again, with our construction, we're using a compass and a straight edge to construct that line segment AB. We have our original segment AB. We're going to take it and we're going to copy it onto a new line segment. So you have AB. We're going to take that. We're going to draw line segment C, a new line. And then we're going to take the measure with our compass, extend our compass so that's open to the length of AB. And then once we have it open to the length of AB, we're going to go down to C and mark off that same distance on the new figure. Once we do, we know that the length of AB and the length of CD have to be the same. And now we have just copied that segment. So now we have two congruent segments. So that's making or copying a segment so that we have congruent segments. And again, we'll go through that a little bit more tomorrow. For now, I'm going to stop the video. I might add a second video to demonstrate the compasses so that you have something to look at. And again, there's a compass on your supply list as a recommended thing where we'll have a class set during class time that you can use. But if you want to go out and get one to practice constructions, you're more than welcome to go out and get one.